I'm Alina Kadlubsky. I'm product designer and web XR developer by day and director of communication and managing director of OpenAI Cloud Europe, and leading the accessibility efforts within OpenAI Cloud as well. I'm today here to represent CyberXR, where I'm chairing the public working group. And thanks again for having me. I'm really excited and honored sharing the virtual stage with all these amazing and inspiring people today. In today's talk, I'll actually like to be speaking about the necessity of having accessibility baked into privacy by design. And that actually leads to, we just around a month ago actually published our first XR privacy framework that's been a collaborative and interdisciplinary effort within XRSI that we're leading the effort together with cybersecurity, privacy, XR, spatial computing thought leaders, and academia. In my talk, I will emphasize on the accessibility needs. And later on today, Kavya will actually go a bit more deeply into the privacy framework that we delivered by itself. Yeah, with any further ado, I think I'll just roll on and continue my talk. So yeah, spatial computing and extended reality technologies provide a bridge that actually combines hardware, software, people, places, information via hardware like head-mounted displays on the VR side, but also AR glasses that are currently a few are on the market, such as HoloLens and Real, and others are coming in. Yeah, from digital contact lenses in the future, I mean, we already seen some quite inspiring research that is done on various sites, including haptic wearables, IoT devices, sensors, robots.
Alina,
yeah.
Excuse me for interruption. We still see just your working PowerPoint screen. Maybe your main presentation is channeled to another screen because we don't see it.
Okay.
So you moved to the full presentation, right?
Yeah.
Okay, so we don't see, we just see the screen, which is slides with PowerPoint. So this screen is probably delegated to another screen. So you have at the bottom of the PowerPoint, you have a bottom slideshow where you need to redirect it to the, in case you are using two screens.
Okay.
If you just press F5, F5 is the function button. F5, you should move into a full screen mode. Okay.
Does that work?
All right. Okay. Great. Go ahead. I'm sorry. Go ahead.
No worries. Thank you so much. Yeah, so with us now transition into this spatial computing area that actually bundles IoT devices, various HMD devices, and basically connects and merges the physical with the digital reality. There's moving forward this emergence of the internet when millions of people across the globe started to connect, brought to light the lack of trustworthy design and abuse of digital systems. The amount of data collected, processed, stored, and ultimately misused gave rise to loss of privacy, misinformation, disinformation, socio-political distortion, weaponization of information, and the introduction of cybersecurity and privacy laws. And we're currently at a stage where the buzzwords move fast breakthroughs doesn't occur anymore. Moving ahead into the spatial computing era, there's so much for us as a society at stake. And moving forward, it's really important that we make sure that we build an balanced out ecosystem that actually benefits all. Making sure that people with special needs, that we build an ecosystem that is diverse and make sure that everybody is included. Emerging technologies such as XR and spatial computing will transform and will impact any aspect of our lives. The way humans interact, create, like you see in the middle slide just recently, Snap launched their AR testbed within AR Cloud testbed within London. So the way humans interact, create, and do commerce and heal. As we are moving away from society where people assume that screen-based input through a keyboard or smartphone is the norm, you begin to see all sorts of applications coming to fusion. For example, autonomous vehicles, utilizing 5G to navigate the environment and send out signals to other vehicles and pedestrians. That really begins to open up huge opportunities. While this technological shift expands our capabilities and increases our potentials and affects our economy, culture, lives, it also creates deeper social and privacy concerns, which need to be addressed in a wide-ranging debate across industries while building our spatial computing ecosystem, because this time around, there's way more at stake for us as a society. Where's the data stored? Where's it progressed? Especially now we have HMD devices, whether VR or AR devices, that are constantly mapping everything, anything at any time. And up until now, there's no regulation or guidelines there that restrict those things to actually secure the users, but also the bystanders. The decisions we are making today have a way bigger impact and effect to our tomorrow. The benefits of extending realities and building mirror worlds are fueled by massive amounts of data that flow through a complex ecosystem. Individuals and organizations are currently not fully aware of the irreversible and unintended consequences of XR on the digital and physical world. With the mass adoption of emerging technologies, it is important to understand the privacy and safety concerns and proactively address them. Informing individuals and organizations about privacy risks should begin by first understanding their privacy needs and expectations. Privacy needs can be derived from individuals' legal privacy rights, whereas the context and choices can be communicated by understanding privacy expectations. Human-centric privacy by design, our XR, the XRSI privacy framework that we've built together with XRSI and Kavya and many contributors, uses this approach with a heavy emphasis on the 7 principles. Combining the principles with the human-centric by design principles, first outlined by the Cyber XR Coalition, and the Privacy XR framework helps to achieve a much needed outcome. So first you have the human-centric by design, which is the triangle in the middle, and accessibility, a human-centric design and development approach for immersive technologies is built on those like 3 pillars that you see here in the center. That includes trust, inclusion, and accessibility. This approach fuels the cooperation of products that resonates more deeply with an audience, ultimately driving engagement and growth. You may ask yourself why these 3 pillars matter and what they actually mean and why they are so important. Starting on top with trust. So trust includes the assured reliance on the character's ability, strength, or truth of someone or something. There is no single recipe for building trust in every system. However, a particular mindset can be established to build systems and applications to promote trust from the ground up. Trust will ultimately define the success of immersive technologies and therefore is a fundamental concept to approaching human-centric design and the development of immersive technologies. On the left bottom, we have inclusion, and inclusion is the act or practice of including and accommodating people who have historically been excluded. 20 immersive technologies provide us with an opportunity to create the future. Therefore, attention must be paid to include all forms of diversity. While building these technologies, we must build and foster immersive environments where everyone feels welcome, despite culture, upbringing, or heritage, or religion. On the right hand, we have accessibility. So currently, digital frameworks were not designed with accessibility as their foundation. Therefore, a post-production movement occurred to make digital systems more accessible and benefit all. With immersive technologies, both the hardware and software of XR should be customizable for all users and specifically for those with disabilities or special needs. Outside of potentially enabling millions of people with impairment, flipping the way we think about technology, access, and data consumption can have wondrous consequences, sparking research with beneficial side effects. There are people who have lived on both sides of the equation, those born with impairments who regain full functionality and others who lost a sense or physical ability. They offer unique perspectives and some drive radical change. Immersive technologies multiply the physical component of that interaction substantially, often requiring full body interactions. When it comes to using VR, standing for long periods, wearing a heavy headset and holding clunky controllers all stand as immediate barriers to entry for many users. Typical current VR system input devices are handheld controllers. Basically, one size fits all users. These controllers assume that users have one or both hands available or use with full articulation of fingers, wrists, arms, excluding situational disabilities, like if you broke your arm or you have a stroller. This can exclude individuals who may have limited mobility or weaknesses, who may not have the expected complement of limbs or digests to produce the fine motor skills which are required to perform tasks in most VR and XR experience, such as selecting, dragging, rotating virtual objects, scaling virtual objects. Many people with upper body motor limitations, the actions mentioned above may be difficult to perform, therefore may be tiresome and lead to a frustrating immersive experience. Similarly, haptic feedback has long been harnessed as a useful signal for the visually impaired to engage with technology, but it's also providing a new dimension, like music listening, and completely changes the way we listen to music, especially when we have spatial sound. You can enhance new ways of connecting and engaging people who are not having the way of sound like we do. You open up way more opportunities to engage with sound on different ways. Cementing to visual circles of innovation, comparing technology has since been used to help hearing impaired users enjoying live gigs, but it also opens up way more possibilities to engage with music in different ways by really connecting them to the physical world and including digital objects. You could engage with different music by standing in different rooms or in different ways of really engaging with music. For this particular scenario, voice interaction is a possible solution for some users with upper body motor limitation, but it should not be considered a solution for all users, as many people with motor impairing conditions such as cerebral palsy and Parkinson's disease may have dissertations, making it difficult for automatic speech recognition systems to understand them. Further considering how to make voice control usable for dense, complex 3D VR scenes remains an open challenge. With current AR headsets, current functionality like hand tracking could be unstable or unusable for many, such as those with prosthetic limbs or limb paralysis. Taking a look at the software running on these platforms, the chances that content will lack accessibility option only rises. Audio clarity, text size, and contrast, button layout options, movement requirements, and countless other factors each contribute to whether an application is going to be a comfortable and accessible experience for all of the users out there. Only if we make hardware and software and building a balanced ecosystem of spatial computing, we can hope for an extended reality design and development that is generally human-centric and accounts for human limitations, whether temporary or permanent. But what is accessibility? Accessibility is basically an ongoing commitment to building technologies that include everyone, incorporating accessibility as a core-centered aspect of the whole process allows every user to benefit. Pursuing accessibility should be more than just making sure you meet a legal requirement or a checkbox for some feel-good public creation or marketing scheme. It is about good hardware and software design, development and coding, appropriate testing and training, and building a culture of care. Mistakes and re-engineering design frameworks are less likely if we build a culture of accessibility from the ground up. Having a diverse team, making sure to test what you've done with a broad audience, makes your product way better and more accessible to any users. Privacy and accessibility, aligning privacy with principles of inclusion and accessibility, and the underpinning reason for implementing accessibility into the working process of privacy and product development is not only because it's the right thing to do, but also because it leads to better, more inclusive digital environments and a culture where everyone feels welcome. Privacy considerations for accessibility are not just about how the data is processed, but also how risk is assessed, managed, communicated, and prevented. The set of controls and privacy measures defined in the XRSI privacy framework, to which Kavya Perlman will follow up in her talk more deeply, provides a comprehensive approach to ensure these considerations are part of the design and development process. Current accessibility laws and regulations, section 504 and 508 of the Rehabilitation Act and American with Disability Act, European Accessibility Act. So there are currently, we have GDPR, COPPA, and others that are currently pushing accessibility as well. And those are the frameworks and laws that have been implemented and included into our framework. Accessibility due to physical cognitive differences and bridging the digital divide. Within aging society, statistics say that by 2050, there will be 115 people with dementia worldwide. That's why it is crucial that people with mild and moderate levels of dementia stay as active as possible and participate in society for as long as possible. However, at the moment, even people with only a mild cognitive decline may find standard applications impossible to use. These evolving immersive technologies are able to further cultivate experiences to suit individual needs and enhance our ability to explore and connect in new, meaningful ways. To better assess, communicate, manage, and prevent risks associated with privacy on accessibility needs, the architects of these ecosystems need to understand these differences and continue to push building the infrastructure of the future of computing further and with responsibility. The CyberXR Coalition and W3C accessibility recommendations. The list of such recommendation laws and guidelines in the uncharted territories of spatial computing XR will continue to evolve. However, as we commence the privacy effort today, the XR privacy framework takes the existing considerations into account to help create accessible privacy controls and promote safety and trust. we need to come together and prioritize accessibility as we further develop these recommendations and frameworks into concrete, actionable items that can be adopted and implemented by organizations, regulators, and bodies globally. Yeah, that's basically it from my side today. Are there any questions out there?